All right, so let's look at these notes. There was no warm up. Sora has narrowed his car search down to two different types of cars. To make an informed decision, he gathered data on estimated highway fuel efficiency, the two different types of cars, the dot plot of the two different types of cars. The dot plots show the data for each type. Okay, so type 1, type 2. If a highway fuel efficiency, down here, is the most important feature to Sawyer. So what is in this chart, which type of car should he purchase, type 1 or type 2? I want to, what do we think? I totally agree, type 2. Now, I want to point out some things that some people would say. Obviously, this one in type 1 is better than a lot of the other type 2s, but it's kind of saying overall, which type should he purchase? And overall, he should purchase type 2. Anybody ever heard of this term called the MAD?
Yes.
Okay. This is what you hate it. Is that what I heard? This is one of those things that I think the state test pushed, and then now we have to teach it. Okay. I had never heard of the MAD before it showed up on the state test. So, what is the MAD? The MAD is the distance the average is away from each point average. Okay. So, what do I mean? We're going to calculate the average or the mean. Then I want to figure out how far away is each of those points. So each data point, okay, from that. And then I'm going to add them up and divide by how many there are, or in other words, take the average of that. Okay? Average, distance from average, and then average. Okay? What this usually tells us is how spread out our data is. So looking at this one here, it says, I told you that the average, I already did it for us just to save some time, is 35.75. Okay? And I want to figure out what is the MAD. So to figure out the MAD of type 1, I have to figure out how far away 35.75 is from each of these points. Okay? The MAD is a little bit maddening, I'm not going to lie. Okay. So 35.75 away from 33. How far away is 35.75 away from 33? 2.75. There are two of those. So we write 2.75, 2.75. How far away is the average from 34? 1.75. We have three of those. How far away is 35 from the MAD? Or the mean, excuse me. Say again? 0.75. Are we understanding where this is coming from? There are three of those. How far away is 36 from the average? So let me clarify. So what I'm doing is here's my average for the first one. And I want to know how far away is 36 from that. It's 0.25, and there are three of them. So I go 0.25, 0.25, 0.25. How far away is 37 from there? 1.25, and there's two of those, 1.25, 1.25. And then finally, how far away is 38? Or not finally, but 38. 2.25. You could put these in your calculator and figure them out that way. But honestly, it's not terribly hard to just do it in our head. 41 is how far away? 4. I think it's more like 5. 5.25. So we figured out the distance that each of the points are from the average. Now what do we do to that? Add them up and divide by how many there are. In other words, the average of these. Okay? So, Mr. McConnell, this is so tedious. Stop. There's got to be a better way. What would be the better way, you think? There's no better way. It's very half empty. We're going to go to our state Desmos calculator. Where is it? Where's mine?
It's
Down. It does? I thought it said state.
No, it's not that one. It's like a graphic look.
Do you see it?
No,
Oh, there it is, state. Okay.
Mine just is
So what I'm going to do is I'm going to find the average, but I'm going to let Desmos do it for me. If I go, this is kind of cool. If I go down, get away. Oh, I don't know why you're in there. Okay. If I go down here and I hit function button, we're doing statistics and I hit statistics. It's going to find all of these things for me. It'll do the work for me. I can find the mean or the average. I can find the median. Remember how tedious it was to find the median? Well, some of these things we don't know yet. Okay. Some of them we won't do this year. MAD is not on there. But all you got to do is find the average twice. So let's talk about, so what I want to do is if I hit mean, it's going to say mean of what? So that's really not how I want to do this. What I want to do is I want to make a table. And I'm going to put my values in here, 0.75, 0.75, 0.75. Oh, I'm not doing them in order. Sorry. 2.75, 2.75, 1.75, 1.75, 1.75, 0.75 3 times, 0.25, 0.25, 1.25, 1.25. Did I make a mistake? There's a 3. I don't have any 3.25s.
No, he's saying there's three.
Oh, there are 3 of those. I only have 2.
The 0.25.
Of the 0.25, there should be 3 of them.
Yeah, you only put 2 on the table.
You're the best. Thank you. You guys are awful. Good morning. Can you come back during IE? Okay. See you in a little bit, bud.
Bye.
All right. Now, what I can do is I can hit that function button. I can go to mean, and I can say I want to find the mean of x1. So then I just type in x1, and boom, it spits out the mean. In this situation, that mean is really our what? It's our MAD. So my MAD for type 1 is 1.625. Mr. McConnell, there's got to be a better way. So let's try to do it all in the calculator. So I'm going to make a new table. And what I'm going to do is I'm going to plug in these values. So I got a 35, a 36. I got 2 37s. I got 2 38s. I got 2 39s. I got 2 40s. I got a 41, a 42, a 43, a 44, a 44, and a 51. In order to do the MAD, I need to know what of these numbers? First step of the MAD is to find the mean. So what I want to do is I want to go down here and I'm going to go, I need to know the mean of x2. So the mean of x2, it tells me is 40.25. It rounded it for us. Okay. So then what I want to do is I need to find out how far away are the numbers from 40.25. How can I take this number and find out how far away is it from 42.5? Exactly right. So I'm going to make a function. Y2 is equal to x1 minus 40.25. If I go up here now, it did it for me. What's the problem with my numbers? They are decimals, right? Okay, I want to figure out the average, or I'm sorry, wait, that messed up, didn't it? Oh, I did the wrong one. 40 next to. Okay, there we go. I thought that was going to work. What's up? No, it's Y2. Didn't like that I did that. What if I do that? No. It's weird. It lets me pull from that, but not from. Okay. So we have to figure out how far away are these numbers from 40.25. So how far away is 35 from 40.25? Say again. 5.25. How about this one? 4.25. It should be that way, right? Does it seem easier to do it here? Nope. Is that right? 0.75?
Oh, yeah.
What's 51? We're talking about the distance it is from 40.25, 10.75. Okay. So now we have the distance, the average distance from that. And what do I need to do with those numbers? Find the mean, the average of that. So then I can go down here and I can just go the mean, and then actually you can just type it in, of Y2 is 2 point. So type 2 is 2.9375. Now remember, we're talking about the distance you are from the average. Okay. So how does the outlier in the second data, so this 51 up here, how is that affecting the mean, and how does it affect the MAD? Yeah. Okay, for the how does it affect the mean? Let's split this up into two questions in the MAD. So how does that outlier affect the mean? Okay. If we have a bunch of grades in this class, say everybody got like a 55, it was a super hard test, but one person gets 100%, how is that going to affect the average? It makes it go up. So this one out here is going to make the average go up. How does it affect the MAD? Goes up because we're talking about how far away is the number from the average. It goes up. The MAD basically tells you how spread out the values are. If I look at this these two MADs, this is 1.625 is the MAD, and the MAD for this is 2.9375. So these are my MADs. Would you agree that this one is more spread out than the first one, the data?
Yes.
Yes. Okay. So what sometimes happens is you might ask, okay, what's the average? But then if you add the MAD into the question, you're also saying how spread out is it? I might say, hey, everyone did well on this test. We have an average of 80. If the MAD is big, what does that mean? Say again. The MAD means how spread out the numbers are. If the average was 80, what does that mean if the MAD is big? The values are spread out. Is that good for you or bad for you? Bad. Or good, depending on which side of the 80 you're on. It means a lot of the values were not close to 80. You know how you do on test. If you usually do really, really well on tests, you're like, sweet, I got like 100%. If you usually struggle with tests, then you might be like the 50%. Okay, so that MAD score is saying how far out were people from 80%. If the MAD is small, then that means most people scored around what? The same. A lot of people scored around the same, around 80%. Okay. Whew. So the MAD is the average, then the distance from the average, and then the average. Okay, that's how you find the MAD. Most questions you're going to get asked is, if the MAD is this, what does it mean? Okay, so if the MAD is like 15, what does that mean? If the MAD is like compared to 1, what does that mean? Okay, so another type of question we'll see is the IQR, and we've talked about this before. It showed up in one of our warm-ups. Okay, so Caitlin and Philip go to neighborhood high schools, and both are sponsoring charity fundraiser. Caitlin claims that the students at her school are raising more for the charity than Philip's. So Caitlin claims that she's doing better. The amount raised by a random sample of 30 students, so that means they didn't collect it from everyone. They just randomly collected from 30 or asked 30 students, is shown in the box plot. Does this data support Catherine's claim? So Catherine claims that she's doing better than Philip. Do you agree? Yes or no? No. Why? Their data is actually exactly the same. As far as, yeah, okay. Okay. Here's a big hint with box plots. You're probably going to talk about what? The median, and what else? Why do we have box plots? What do they show? There's a word I'm looking for. It's only box plots have these. The quartiles. So we're going to probably say something about quartiles. What percentages show up when we talk about box plots? 25%. What else? 50%, 75, 100. So we're going to probably want to say something about one of those percentages. Is Caitlin doing better than Philip? Okay, so we already say no, but why?
She's more spread out, but his averages are closer to a higher number.
Okay, there's no average on here.
Or like his median is closer to a higher number.
Okay, say that again.
His median is closer to a higher number.
Okay, okay. Let's talk about percentages. I would accept that answer if you just said his median is higher. Okay?
Most of it is like higher.
Most of it's higher. Give me one of those percentages that Parker named off. What about 50%?
Their 50% is at a higher number than Caitlin's.
Okay. Yeah, so any of that stuff would be true. Now, here's the thing about statistics. You could say all kinds of things. You might argue, hey, their max and min are exactly the same, right? But we said that Philip is doing better. So Caitlin could be like, what do you mean? My person who's raised the more money has raised exactly the same amount as your person, right? Here's what I kind of want to point out. Her 50% is his what? 25. Okay. So and we can say that about his median. Her median is lower than his median. But that's where you got to be careful with who's giving you the information. I could give you this, we could look at this chart, and that's where the chart is better than someone just telling you what's going on, right? Because looking at the chart, you go, oh, okay. When somebody gives me a statistic, they said the other day that a lot of teachers have been quitting after the first couple years. And I go, I want to see what the data looks like. So I looked up and they had charts like this. Okay, that's better than just someone saying Philip does better. Okay, this gives you more information. Okay, how does the IQR? Does anyone remember what the IQR is? Yeah. Okay, and how do you find it? Okay, good. Anyone remember?
Don't you,
The average.
no, you take what the average is and like
There's no average on this chart.
the number in the middle, median, and then take the number in the middle of the first half of it, right?
Not quite.
Take the lower part of it, like, I don't know how to explain. What's the second?
What is this? What do we call this?
Yeah, the box.
The box. Take the lower value of the box, which is 32 here. The higher value of the box, I think, is that 52?
Yeah.
Okay. So Caitlin's is what? It's 20. Yeah. How big is the box? And then Phillips is, what is that, 45? Up to, does that look like 55 to you? 56, okay. How big is Phillips' IQR? 11. So what does that tell you?
That she has gotten like a wider range of foods, like, and then he has gotten like a short.
Yeah. So not only is his median higher, but what's true about the people?
They've like voted higher for it. Like,
Right. It's collecting money, but go ahead.
It's like he's gotten more higher votes than he had. Like that she has like some high, some low.
Right. So it means of his median, which is 50, and of her median, which is, what does that look like, 45, roughly? Who are more likely to be close to 50 or close to the median? Who's more likely to be close to the median? Caitlin's people or Phillips' people? Phillips. The lower the number, this is kind of like the MAD. The lower the number, the more likely you are close to that median. Say again?
Is it not the
This is not the MAD, but it's a similar concept. Okay?
What's the difference?
Here, well, remember how we calculated the MAD?
Yeah.
And it was all that work. Even when I put in the calculator, it was all that work. This one is just how far away is the bottom of this box to the top of the box.
Yeah, but I know it's like different. It's pretty much the same.
It's similar information. Yeah. This is a lot easier to figure out than the MAD. Okay. Marketing team compares the age of a random sample of 30 viewers to the top to two popular shows to decide which product to advertise during each show. During which show would the marketing team advertise a product that is targeted for 20 to 29-year-olds, which is this one. Show 1, which is here, or show 2, which is here. What do you want to do with these histogram plots? Say again. So these are the only shows that are available to us. I don't think either of them are great because we're trying to hit 20 to 29 and it's not very close to that. Which one's better? Show 1 or show 2? How do you know?
Because it has more.
You add them together.
Okay, we can add, how much is this right here? Say 3. And how much is the other one? 5, which is 8. And how much is this one? 8. Which one's higher? They're the same. Which one would you go with? This is where data is weird, right? Because I can go, this one is better because it has 8 and the other one has 8. Well, you're like, wait, they're the same. So this is going to be an opinion. What would you do? Yeah.
I would pick 2 because it has a bigger range of the one that we're targeting.
Yeah.
The other one is more just 25.
Okay. So he likes this one because it's going to hit more age range. I think life is a little bit easier if we give this a product. What is this product? What do 20 to 29-year-olds want to buy? A car? Okay. How about let's go specific car. What kind? Okay. So let's say a cheap car. Because that kind of makes sense because when you're young, you're going to want to buy a new car, but maybe a cheaper one. When you start making more money, you might want to buy a more expensive one. Which of these would you go with if it's a cheap car? And you know that people over a certain age aren't going to be interested at all. So 1? Okay, why? Okay. So let's just calculate these different numbers here. We got 4, and then this one is also 4, is that right? And this one's 4. And then we don't really care about these people because they're going to want to buy a more expensive car. Okay. This one is 10, I think 7, and I think 5. So is there a wrong answer of which one to go with? No, it's about the explanation. So someone tell me which one to go with and why. And we're going to go with that.
2.
Type 2. Okay, type 2, and you may totally agree or disagree, I mean.
Because for type 1, it only target 24-year-olds.
Okay.
Type 2 does.
Because type 1 misses all 20 to 24-year-olds. Someone else said type 1 because it's going to cover, it misses some people, but it hits all these people closer to that age. Okay? Both are correct answers. Again, this is where data gets kind of weird. You can kind of spin it however you want. It's more powerful to see the actual data, the actual charts, than to get someone's opinion. Hey, I looked at these charts and my opinion is this, right? Well, you should be like, I'd like to see the charts, okay? Because they might really sell this one and you're like, I've got some problems with that one, okay? Any questions on that? All right. Nadia, is that right? Collects data from 15 classmates about the number of text messages they send on a school day and the number of text messages they send on a non-school day. Nadia organizes her data into the tables below. How can you use a box plot to compare the data that she collects? So it's not asking us to make one, but how is it going to help us?
Because it will tell us
It'll show us the range.
It will show us like the exact average of.
What's not in a box plot?
The average.
The average is not in the box plot. What's in the average, or what's in the box plot? The median. Okay. So say it again, but say median this time.
It'll show us the exact median for average.
Okay. So we can say we can compare the median. What else does it give us?
It's the quartiles.
Okay. The quartiles. What else does it give us? It doesn't give us the MAD,
Maximum.
the max, and min, and then the last thing that we just talked about in the IQR. How this question might show up if it was multiple choice. It might say something like, we can compare the averages. Would that be the choice? No, because the average isn't in there. Okay. It will help us find the max and min. Yes. We can see in the box plot, we can see individual people's data. Can we? In the box plot, we can see individual people's data. No. Okay, so that's the kind of question that we might get on that. Okay. Bunch of vocab. Yeah. Symmetrical data. What does symmetrical mean? The same how?
If you cut it in half, if you fold it together, it's the exact
Exactly right. Cut it in half. What's something that's symmetrical?
Circle.
a butterfly.
A butterfly. So you take the butterfly, you cut it in half, fold it, take a picture of a butterfly, you cut it in half. Okay. So symmetrical data, what do you think that's going to look like?
It's kind of like the exact on both sides.
Same on both sides, right? So if I have a 1 here, and then maybe a 2, and then maybe a 4, then what would the other side look like? It would look, yeah, it might have a 4, and then it'd be like this. Usually data is not perfectly symmetrical, but you could say it's close, close. How does an outlier affect the median? So let's let's just make up some points. So 1, 2, 3, 4. This is the age I took my first step.
4?
I don't know. I'm just making something up.
That's not.
And there's an outlier.
20.
Yeah. I just,
I mean, maybe they have less.
how does this outlier affect the median?
It's gonna make it bigger.
No.
It's gonna make it.
How does this outlier affect the median?
It's gonna make the data more spread out.
So what is the median of this? 3. If I change this number and change it to not an outlier, it'd still be 3. So how does an outlier affect the median? Not much. You could argue that it affects it a little bit. If I took this away, right, then it's 2.5. But if I add this crazy outlier, what is an outlier? How does it affect the mean?
Makes it bigger.
Makes it bigger, a lot.
Wait.
Pulls it up or down.
Up.
In this case, it would pull it up. If I did an outlier the other way, it could pull it down. That's why we like to ask the question, what's the mean and what's the median, right? If I say my median on a test is 80%, that means 4 people could have failed it, right? If I say my mean, then it's going to give me more information about about the overall. Okay. If the mean is bigger than the median, Okay. So let's see if we can come up with this. If the mean is bigger than the median, is the mean on this going to be bigger than the median?
No.
Yes.
Yeah.
Okay. What does that mean?
It means that there's an outlier
Where?
at the end.
What be? Let's use left or right.
What?
Left or right?
Right.
Right. This means we have an outlier on the right. If I were to plot these, right, we got a dot, we got a dot, we got a dot, and then we got this dot out here. Okay. This is called skewed. If you're building something, do you want it to be skewed? No. So this has been skewed how? This has been kind of messed up which way? Right. So they call this skewed right. If the median is bigger, so let's say I change this and all the numbers are now 16. First time I drove a car,
Isn't that illegal?
it is illegal. I didn't say legally drove a car. What that means, the median is now bigger than the mean. So what's true about the outlier here?
Skewed left.
It's skewed left, outlier on the left. I get confused in my brain, so I like to just make up data when I do this, right? I can quickly go, okay, the median is smaller than the mean. That means there's a value that's over here. The median's 17, but the average is down here because of that weird 5. Okay, and that helps me out. Consistent. Would you say that these values are consistent? No. Why?
Who's the outlier?
Outlier. So if I take away this 5, it seems more consistent, right? It's around the same age. So we say that that's a close cluster, which means the MAD would be what?
Like 1.
It'd be small, like 1. And our IQR would be what?
High.
Try again.
Low.
Correct. First try. Okay. And all of those, the lower the number, the closer the cluster. Our MAD, we just kind of said this, but if it's a low, that means what?
It's a cluster.
Close together. Or a close cluster. And if it's high, that means what?
Spread out.
Spread out. Perfect.
But it's higher than profoundly.
A lot of the questions are going to be more about what does that mean than finding the MAD. Variability. What does it mean to be variable? Variability.
It means you can vary it.
So if I say it has a low variability, how much it varies is low.
It's close together.
Close,
Oh, close.
right? They're closer together. And if I say it's a high variability, it's all over the place,
Then it's spread out.
spread out. Kind of a bunch of different ways of saying the same thing. We talked about how to find the mean, right? So you can literally just type in mean and it's going to get that for you. I'm going to come back to the stat one here in a second. Correlation types. We have type 1 where the dots are like this. And we call that what? Say again? I'm trying. It's a positive. It's okay. So that's a positive. And it could be linear, but we're not asking that this time. What's the other type?
Negative.
Negative. And then the third type is what? None, right? And really it would be no correlation.
Perfect.
Fun job.
Stats. So this little thing right here indicates that you can do these in Desmos. You're like, Mr. McConnell, I hate doing box and whisker plots or box plots. They are so painful, so hard to do. There's got to be a better way. So if I come over here and I want to do a box and whisker, it does not do it for me. You're like, the regular Desmos will actually do it for you. State test comes up and you go there and you're like, I want to do it on the state test, but I have to take all this time to do it. And chances are they're not going to make you do one, but they're going to show you one. But if I had to, for homework or online work, do a box and whisker, what do I need to know to do a box and whisker plot? So I'm gonna do a box and whisker for this guy right here. I need to know what? The median, and what else? The quartiles, and what else? Maximum. So watch this. I can go here and I can hit. Oh, where'd it go? I can go to stat function, and instead of doing all of these individually, if I just go to stats, oh, not there. If I go to stats and I want to do the stats of X1, it gives me the min, quartile 1, the median, quartile 3, and the max. So then all I have to do is go, okay, it's from 0 to 26. I kind of want to do it at scale. 22 is roughly here on that scale. 17 is roughly here. And 9 would be a little bit closer. So it tells me my min, my max. It tells me my first quartile in my third quartile in my median. Boom, done. Wouldn't you have liked to know that yesterday? So that stat function gives you all the things you need for a box plot.
So all we should do is type in the values
I typed in the values
and then like stats.
and then stats. I personally like to just hit stats. I'm sorry?
And this is for the state test?
Wait, can you go up? Okay.
I got 3 different questions. Sorry, Maya first.
I was just asking if that's all I have to put in, and then can you write like stats instead of having to put it like.
Yeah, you could type in the word stats. See how it doesn't know what you're doing, but as soon as you do all the letters, then it's like, oh, I know what you're doing. Got to then put it stats parentheses of what?
X1.
Yeah.
X1.
And then I'm like, oh, I also need to know the mean of X1. Boom. There's the mean.
That's kind of cool, man.
Yeah.
This is what we can do on the state test?
This is a state test calculator. The regular Desmos calculator,
I'm not gonna create one.
which you can't use on the test,
What the?
where is it? The regular graphing one, which you aren't allowed to use, has, and someone found this yesterday, has, all right, here, box plot. It'll just do it for you. Histogram, dot plot. It'll do all 3 of those for you.
Cool.
That is not on the calculator that you get to use on the next test or the state test. Okay? But just use stats and it basically gives you all the information. All right.